In chemistry, we describe water as a polar molecule. Where have we heard the word polar before? If you're like me, the first thing that comes to mind is probably a polar bear. But water is not a polar molecule because it's a cold molecule, or even because it's anything to do with snow and ice. The best link to our previous understanding of the word polar is actually north and south poles. That is, the top and bottom ends, if you will, of the Earth's axis. More on this in a moment. Here's a picture of the atomic structure of a water molecule. Look carefully at the position of those red electrons. Notice where they're grouped. Now, somebody asked recently, when we draw an atomic diagram, does it matter where we draw the electrons? Well, not really when drawing a single atom. But yes, it matters when drawing a water molecule. Due to that strong positive charge on that single oxygen atom, the group of electrons with their negative charge are attracted to that oxygen atom. They spend much more time hanging around the oxygen atom. The result is that the oxygen end of the molecule has a slight negative charge overall, and the hydrogen end of the molecule is left with a slight positive charge. So at this point, we must understand that this positive and negative charge is only due to the positioning of the electrons. It's still true that one oxygen atom has more protons than one hydrogen atom. But we are focused on the position, the grouping of the electrons. It's this grouping of electrons that results in the positive and negative ends of the molecule. A better word for end is pole. So we can say there's a positive pole and a negative pole on the water molecule. To summarize, due to the unequal sharing of electrons between atoms, the oxygen pole has a partial negative charge and the hydrogen pole has a partial positive charge. And therefore, we say that water is a polar molecule.